to test for chloride, bromide and iodide have a similar test but different observation. Or they are also known as halide ions. Chloride, bromide and iodide, they are also known as halides. The term halide here is from halogen, and halogen means a salt former. If an element has a tendency to form a salt, we call that halide. So group 7 are known as halides because they form salts. They're all compounds are salts. So chloride, bromide or iodide, if you want to test, they have the same test. The test is add a small amount of acid followed by silver nitrate or lead nitrate. So this is a test. Either you first add a very small quantity or small amount of acid, and then what you will do, you will add silver nitrate or lead nitrate. Silver nitrate is AgNO3 and lead nitrate is PbNO3 in a bracket 2. Why? Because lead valency is 2. That's why it's lead 2 nitrate. So AgNO3 or either one of them, not both of them together, either one of them you will add a silver nitrate or a lead 2 nitrate. What will be the observation? Like you may have a chloride ion, you may have a bromide ion, and you may have iodide ion. So if there is a chloride ion, what is the observation? You will observe white precipitate. This column is for observation. So if there is a chloride ion, the observation is a white PPT. And this white PPT or white precipitate is due to silver chloride, formation of a silver chloride or lead 2 chloride. If you add silver nitrate, then it will form silver chloride. If you add lead nitrate, it will form lead 2 chloride. Both appearance is white. If bromide ion is there, then what is the observation? You will observe cream color precipitate. And this cream precipitate is due to, if you add silver nitrate, then cream precipitate are silver bromide. If you add lead nitrate, then it is lead 2 bromide. So after a small amount of acid, we add silver nitrate, and these are the observations. If there is iodide ion and you add silver nitrate or lead nitrate, what will be the observation? You will observe yellow precipitate. And these yellow precipitate are due to formation of, because sometimes they ask, state the formula for the precipitate. So yellow precipitate, if you add silver nitrate, then it is silver iodide. If you add lead nitrate, then it is lead iodide. So test is same for halide ion, observation is different. So if you add small amount of acid followed by silver nitrate and lead nitrate, you will observe white precipitate. If silver is there, if chloride ion is there, you will observe cream precipitate if bromide ion is there, and you will observe yellow precipitate if iodide ion is there. You have finished, Shubhra? This is a test. Again, you have to memorize. And now these are the tests for the negative ions such as chloride, bromide, and iodide. Okay, I'll move on to next test, which is about the sulfate ion. So if you want to test the sulfate ions, sulfate means SO4. So what is the test? The test is add a small amount of acid followed by barium nitrate or barium chloride. So if you want to test a sulfate ion, what you will do, either you will add barium nitrate or barium chloride. So if the sulfate ion is there, when you add barium nitrate or barium chloride, what will be the observation? The observation is white precipitate of barium sulfate. So both cases, if you add barium nitrate or barium chloride, it will turn into barium sulfate, and barium sulfate is white in color. So this is a test for sulfate ion. Sulfate means SO4. If a salt is having SO4, sulfate ion, you add barium nitrate or barium chloride, you will observe white precipitate. Okay. Yeah, it will give white precipitate with both barium salt. Even you are using a barium nitrate or you are using a barium chloride, the result is same. It will be white precipitate. This is a sulfate ion. Finish done, everyone. For sulfite ion means SO3 with a charge -2. So the test for this sulfide ion, we will add hydrochloric acid. Here we cannot add any acid. Specifically, we have to add hydrochloric acid. So test, add HCl and warm the mixture. So when we'll warm the mixture, what we will observe? We'll observe a pungent gas pungent here refers to irritating. So a pungent gas, basically the gas here is sulfur dioxide, SO2. If gas is tested with acidified potassium manganate, it will turn purple potassium manganate to colorless. So basically potassium manganate are purple in color, and sulfur dioxide has a tendency to convert potassium manganate from purple to colorless. These are the tests for negative ions. Yeah, warming is necessary. Otherwise, if you are not warming the solution, the sulfur dioxide gas won't be released. So you have to warm it. To release the gas, you have to warm. Yeah, we can perform the same test. Sulfate and sulfite both will give a white precipitate, so you cannot distinguish whether it is sulfate or sulfite. Like if you add a barium nitrate, the previous slide, like if I add barium nitrate or barium chloride, that will also give a white precipitate with both sulfate and sulfites. And the last one is a test for nitrate ion. So nitrate ion is basically NO3 with a charge -1. The test is add sodium hydroxide and aluminium, then heat. What will be the observation? In this case, again the pungent gas is there. But in this case, the pungent gas is actually ammonia, NH3. And if the gas is tested with moist or damp red litmus, it will turn blue. So this is the last ion which you have to learn, the nitrate ion. We add sodium hydroxide and followed by aluminium, small amount of aluminium metal. Okay, so after this, the main thing is how you will use these results, test and observation to work out the salt. You may find it difficult for a time being, this memorization, but once you memorize, you don't find the question related to this as difficult question, because it's totally based on your memorization of the test. So I will discuss some questions which will improve your understanding of the topic. Right now, because you have all the tests, you have the test for the positive ion and you have the test for the negative ion. So we will discuss. You can use this table to identify the ions. Finish writing the nitrate ion, so I will move on to the questions. Okay, this is the first question. Now every class will discuss at least one question, so you will have an idea and you will be used to how to use the table. Today we'll discuss 2-3 questions, but now onwards every class will discuss at least a question so that you have understanding of how you will distinguish between different types of positive and negative ions and identify the salt. I will read the question and I'll explain each statement. So here, mixture of two solid compounds D and E. So one of the compound is D, another one is E. And solid D is zinc salt. So solid D is a zinc. But what else with zinc we don't know. We know the positive ion is zinc, but we don't know the negative ion. And which is soluble in water. So D can dissolve in water. Where solid E was an insoluble metal carbonate. So E is there. It's a metal carbonate. We don't know which metal is there, but we know there is a carbonate ion. The test on the mixture and some of its observation are in the following table. Complete the observation in the table. Now, first thing, is it clear that the question like salt D is a zinc salt and salt E is a carbonate, but we don't know which carbonate. And one more point, E is insoluble and D is soluble. Now, this is what about a half of the mixture of D and E was placed in a test tube and the mixture was heated. Means you have two salt, you have a mixture of the salts in a test tube. And you are heating the salt. The solid you are heating. And what you observe a condensation formed. Some water droplets are formed on the mouth of the test tube, at the mouth of the test tube. What you can conclude is condensation. So what this gives an idea, whenever you heat a salt and a condensation or a water droplets are formed, so this shows that this salt may contain some water. Or this is a hydrated salt, because hydrated salts on heating, they release their water molecule. Is it clear, the first test? So about a half of a mixture of D and E, we place in a test tube and we heat them. When we heat, we observe some water droplets or water vapors are formed or condensation formed. What it shows that this is a hydrated salt or this salt contains water of crystallization. What about this color of the salt? Whenever the compound is having a color, this gives an idea that there is a transition element present. If it is a group 1, 2 or 3, in next chapter you will learn about the transition element, so I'm not going in detail. If it is group 1, 2 or 3, then the salt should be a white solid. So first thing, a colored salt shows that there's a transition element. Second thing, if a condensation formed, so this gives an idea that this salt is a hydrated salt or these salts are hydrated salts. So the first observation, you should understand the question. Once you understand the question, you can answer the later part of this question. So a colored shows that there's a transition element. Condensation or water droplets shows that it is a hydrated salt. So first thing, you have a mixture of D and E. What you did, you heat them. You heat the salt. So when you heat the salt, You observe a colored salt is there, it means there is a transition element present. And if condensation formed, it means that it contains water of crystallization, or it is a hydrated salt. Now what we did, the rest of the mixture of D and E were added to a distilled water. So we have D and E, and we add a distilled water. D is soluble and E is insoluble. And then what we did, the content is filtered. The filtrate and residues were kept for following test. So if I add a water and then filter, what will be filtrate and what will be residue? If I add water to a mixture of D and E, I have a mixture of D and E. I add water and I filter. What will be residue? Residue means what left on the filter paper. And filtrate means what passes through the filter paper. Yeah, so D is filtrate and E is residue. Yeah, that's correct. Yeah, that's right. So D is filtrate and E is residue. And now what is the test? Test on residue. Test on residue means what? Residue was what? Residue was E. And what is E? They already mentioned in the question. E was metal carbonate. Metal is there and then carbonate. Which metal we don't know. So this salt contained carbonate. Now in a test, a residue was transferred and about 3 cm cube of sulfuric acid was added. If I add an acid to a salt which contains carbonate, what will be the observation? If a salt contains carbonate and I'm adding an acid, what is the observation? First observation, the gas was tested with the first thing, what you will, the lime water will turn milky, but what is the first observation? So the observation is fizz, bubbles or effervescence, and the lime water will turn milky. Yeah, colorless gas, fizz. Look, when you add water and filter, so two things will form. One will be the residue. Residue means that what is left on the filter paper. So left on the filter paper is E. Why? Because E is insoluble. And what passes through the filter paper, that is filtrate. So D is a filtrate. They mentioned test on the residue. And already you know residue was E. And what is E? E is metal carbonate. Any metal is there and there's a carbonate. So we know carbonate ion is there, but we don't know which metal is present. So if the carbonate ion is there and you add an acid, so what is the observation? Whenever there's a carbonate ion and you add an acid, so observation is bubbles, fizz or effervescence, and the lime water will turn milky. That's why I mentioned fizz. And then the gas was tested with the lime water. The lime water will turn milky. Is it clear? Next, to the first portion, we add sodium hydroxide, little at a time. If I add small amount of sodium hydroxide and I observe blue precipitate, which positive ion is present? Which positive ion is present if you observe blue precipitates? So you can use the table, the positive ion. This is a test for the positive ion. So whenever a blue precipitate is there, this gives you an idea that copper 2 ion is there. So this confirmed that this is copper 2 ion. So this, now you confirm about the salt because E was metal carbonate. This is all the test on the residue. So it contained a carbonate, that's why the lime water was turned milky. And then you add sodium hydroxide, you observe blue precipitate. So this shows that the copper ion is there. So basically what is E? Compound E is copper carbonate. Carbonate is already given. Copper is what you identify from the observation which is given in the question. Same way to the second portion, add excess of aqueous ammonia. If I add excess of aqueous ammonia, what is the observation? Because of blue precipitate, it is copper 2 ion. Aqueous ammonia. Check what is the result with aqueous ammonia when you add an excess. Yeah, so it will form a dark blue solution. So when you are adding, so first it will form blue precipitate which will dissolve in excess. Is it clear to everyone or any doubt in this? Blue precipitate will dissolve in excess of aqueous ammonia. So look, I'll repeat. Less than a minute left, so I'll repeat quickly.